Saxon Algebra 2, Lesson 49. Welcome, students, back to math. It's 2021. We have a fresh new lease on life. And we're ready to dive back in and just do this big. The first part of the first lesson about linear intercepts annoys me a little bit. I will be honest with you. But let's just pretend it doesn't and tackle it. It's not hard. It's just I don't like the way John presents it, and I don't like what you have to do these problems. What we're looking at, if I can get my light rearranged, we're looking at a scenario like this down here. We're used to seeing problems like this where our line crosses the y-intercept and we can easily identify what the y-intercept is. But what if you have a problem with a graph like this where you can't see the place where the line crosses the y-intercept, and we have to figure that out for ourselves. Okay, here's what you do. You have to examine the graph, and you have to find two places where the line crosses exactly at the corners of John's graph paper. Look how tiny everything is. It's so annoying. It's really hard to do. I don't like these problems for just this reason. But if you look, you will see that there's a point right here at, what is that, 4, 0. And then up here at 3, 6. All right, I'm going to draw that on my paper so you can see it a little bit better. I'm just going to draw the part of it that we need. Okay, it was like this. The one point we identified was 3, 6, and 4, 0. Okay, so the line was fairly steep and it was traveling like this. So this was 3, 6, and this is 4, 0. By drawing a triangle, right, this is the distance between the points, and this is the rise over the run. We can see that we went from 0 to 6, and then we went from 3 to 4. So the rise over the run is 6 over 1. So now we know the slope of our line. We got that by inspection. I do not like to calculate my slopes by looking at the graph. It's a dumb way to do math, you guys. It's great for bird watching to look at things closely, but I don't like this. That's what I don't like about this problem. Now, once we've identified that though, what we do is first we need the slope, and then we need one pair of points on the line. Okay. We could use this point or that point, whichever one we liked. Those are two perfect examples. We could have used any of the other ones in the picture, but again, we really want to pick something where it crosses right at the intersection of the graph paper, and that's really hard to see on John's pictures. So I'm going to use this one. Now what we're going to do is we're going to take our line, which we're familiar with, and we're just going to plug in the way we have done before. So y is 0, m is 6, x is 4, and then b is the mystery. This is 6 times 4 is 24. So to isolate b, we're going to subtract 24 from both sides, and we'll get b equals minus 24, which I got right there. I didn't feel like drawing it that way. So now we can write I did something wrong. This should be a minus 6 because it's actually the sink over the run, isn't it? Right? We're going from here to here. We're going down and over to the right. So this should be a minus 6. That should be a minus 6. This is a minus 6. That makes our number negative 24. So when we add 24, our value for b should be positive 24. My bad. Please forgive me. This was where I made my mistake. Now we can write our final answer. Y equals minus 6x plus 24. So we found, the whole point of this part of the lesson is just to say that you can find the equation of the line just by the picture and calculating the slope rather, by looking at it, if you don't screw it up like I did. All right? Now, here's what's cheating. That doesn't even count, you guys, as a example. That's just John having fun. Can you believe it? I'm so offended. Transversals. The second part of our problem, the geometry part, the second part of our lesson is where we're going to have fun. All right? And I can hear your eyes rolling. I can hear you guys. Don't even worry. We have a picture that looks like this. We have two lines that we're calling 1 and 2. They are parallel. Oh, that's interesting. We have a triangle up here. We're told this is B, and we're told this is A, and we're told this is 7. And this, it's not super clear, but that angle is angle P. And this angle down here is angle Z. And this angle here is 153 degrees. And we're supposed to find A and B. I'm going to rate solve for, because that's longer than just writing find. Okay, so let's look at this. We go, okay, finding the sides. We can't use Pythagorean theorem because we only have one of the three. We would need two of the three. But we can use trig functions. If we have either two of the sides, well, we don't have that, but we could do it if we had this angle measurement. But we don't have this angle P, right? If we had P, we could use that to find, it would be sine for the opposite and cosine for the adjacent. Is there any way we can find this out? Oh, well, let's keep going down here. Oh, wait a minute. How does this work again? If this one is 153, then Z must be, what, 27, right? Because these two have to add up to 180. So if this much is 53, then Z has to be equal to 27. And if these lines are parallel, and this is a transversal that cuts across it, then P has to be equal to 27 degrees also. Oh, that's kind of fun, right? So B, we can find by saying let's see, this is the sine, so it's the opposite. The sine of 27 degrees equals B over 7. And then we can clean that up by writing 7 times the sine of 27 degrees equals B. And you can put that into your calculator. Do 27 sine times 7. And what you should get is 3.15. Okay, that's rounded, so check your rounding and be careful. And then to find A, we'll do the same thing, only we'll use cosine because that's the adjacent side. So we'll say the cosine of 27 degrees, I know my hand's in the way. The cosine of 27 degrees, that's this angle, adjacent over hypotenuse, equals A over 7. Same as what we did here. Then we'll cross multiply and kick that up. 7 times the cosine of 27 degrees equals A. And then when you run that through, you'll get A equals 6.23, rounded. So we have found the lengths of the sides, even though we didn't know this angle, by using this transversal information and calculating our way back up. All right, these are rounded. You may round slightly differently, but that is how that works. All right, let's try one more similar to this, but that you pretty much have the gist of it right there. We shall do the next one. Did you guys notice I started a new notebook today? We filled it up right at the end of last time. Example 49.2. We've got two lines that are parallel. John's calling them 1 and 2. That's cool. That little sign is all we really need to know. Then we have a triangle that goes up here. comes down. As we're writing this, we're going, oh yeah, transversal city right here, right? There's that. This is called A, and this time you put that little mark there. 90, N, M. This time he tells us this is B. Okay, we can see, yeah, those line up. We don't know either one though. We really want to know this measure. If we knew B, we know they'd be the same, but we don't have that either. But, ready? This is 158 degrees on this side. Okay, so now we can start moving forward because we know these two have to add up. So this has to be B equals 22 degrees, right, to make that 180. And if B is 22, then A has to equal 22 degrees. And now we can do the same thing we did last time. We'll start with M. M would be cosine because it's adjacent, right? Let me just write these out. Sine, cosine, tangent. Oscar had A hold over Arthur. If we want this side, we've got the hypotenuse. So I want to use that in my calculations. I don't want to get messed up with tangent. So I know that the cosine of 27 degrees will equal M over 90, right? Adjacent over hypotenuse. Cosine, adjacent over hypotenuse. And I know that to get N, I want to use the sine because that's opposite. The sine of 27 degrees will equal N over 90, okay? Now I know that to do my calculations, I'm going to bring this up, which is essentially cross multiplying. And then to get my answer, I'll do 27 cosine times 90 equals. Same for this one, 27 sine times 90 equals, and M will be equal to 83.7. That's a rounded value. And N will be equal to 33.3. Grab your calculators. I'm sorry I can't show you this because my phone is busy filming. But make sure you can get these answers and let me know if that's causing you any drama whatsoever. Okay, that is the end of our beloved Lesson 49. Lesson 50, you guys, is one of my favorites of all time. So I will see you in Lesson 50, and just get ready because I'm going to be smiling. I'm going to be pumped out of my mind, all right? Lesson 50 is coming soon. Goodbye.